Teeth have complex and unique shapes. In prosthodontics, the ability to observe and analyze shape and how these shapes relate to each other is critically important. I'm Dr. Paula Flynn from the Department of Restorative Dentistry at the SUNY at Buffalo School of Dental Medicine. All objects have a shape. Shape refers to an object's flat, two-dimensional geometric configuration of height and width. We know this ball is a three-dimensional sphere, but its shape is a circle. Dental terms used to describe an object's shape include height of contour, undercut, infrabulge, suprabulge. As these dental terms are explained, it can help to remember the definitions of concavity, meaning curving in or hollowed inward, and convexity, meaning curving or bulging outward. The greatest bulge or convexity an object has with respect to its orientation to the vertical plane is known as its height of contour. To help identify the greatest bulge or height of contour, it helps to put a straight edge or ruler at the bulge or convexity and look for triangles of light that form above or below the contact with the straight edge. The degree of convexity and concavity can change if the position of the object is changed in relation to the vertical reference line. Undercut is the portion of a surface or an area of space below the height of contour. Undercut can be represented as a triangle with its point at the height of contour and its base on the horizontal plane. Undercut is also known as the infrabulge area or downward facing surface. The upward facing surface above the height of contour is known as suprabulge. Part of the plan for designing a prosthesis is identifying the path of insertion. This path is the movement of the prosthesis past the surfaces of the teeth to come to rest and be supported by the teeth. When considering the path of insertion for a dental prosthesis, the ability to identify slopes, convexities, and concavities is important. For both fixed and removable prosthodontics, the path must follow parallel or relatively parallel surfaces. Otherwise, the prosthesis will not seat. The contact points of the prosthesis and the teeth must fit together exactly, like puzzle pieces do. Think of multiple proximal surfaces as multiple architectural columns or multiple parallel surfaces. These parallel surfaces are incorporated into the final prosthesis, replicating the path of insertion we have chosen. Any rigid part of the prosthesis will have a final position below the height of contour, must slide past the height of contour, and will not contact tooth structure below the survey line. To help identify contact with a vertical reference to a surface and the amount of curvature at the contact area, look for triangles of light that are formed when the vertical surface contacts the tooth at the height of contour. There will be suprabulge and infrabulge triangles of light. These concepts can be observed in nature. We can observe the greatest bulge or convexity and its related concavity. Practical suggestions on the conscious observation of shape are found in Greg Albert's book, Drawing, You Can Do It. These include: look for the silhouette shape, the outer edge or outline form. Notice the negative shapes or spaces, shapes between and around things. Use a measuring device. Look for alignments, Notice how various parts or points line up or form geometric patterns. Think shapes as you observe: circles, angles, squares, triangles, and so on. With experience, we can train our eyes to analyze shape. A dental surveyor adds precision to the analysis. The surveyor is a paralleling device used to make measurements. We use it to plan and develop a well-fitting functional prosthesis, as well as determine the path of insertion for the prosthesis. This is a surveyor's stand or table. A cast is secured to the stand for analysis. The stand can be adjusted into a variety of positions. Small items that attach to the surveyor are stored under the screw-on cap at the top of the vertical arm. For access when surveying, they are placed into holes on the base adjacent to the vertical arm. The rods and gauges are secured into the vertical arm of the surveyor. There are 3 different gauges that measure hundredths of an inch: 0.01, 0.02, and 0.03. These gauges correspond to the size of the disc at the end of the shaft. Some gauges are color-coded. Gauges that are not color-coded have 1, 2, or 3 lines scored on the shaft for identification. While the analyzing rod is quite rigid, it is possible to bend it. The rod must be true or absolutely straight to be accurate. To check for this, roll the rod along a counter. No wobble should be observed. To safeguard the rod, do not bump it with the cast. Do not use it to secure the cast on the stand when transporting the surveyor. In fact, it is safest to never transport the cast on the surveyor. To use the surveyor, start by securing the cast to the surveyor stand with the flat base of the cast contacting the stand. It is critical to have a stable, secure contact of the cast to the stand. The anterior of the cast should contact the single upright, and the posterior should contact the 2 uprights on the stand. If the cast is mounted, it is more difficult to secure it on the stand. If there is sloping plaster that does not allow stable positioning, the plaster can be trimmed to produce a flat surface for the upright to contact. At times, the cast can be secured by placing a tongue blade against the mounting ring and the 2 posterior uprights. If the cast is mounted on a 2-part magnetic plate, the whole plate must be unscrewed from the articulator to provide a flat surface to sit on the stand. Otherwise, the projections from the plate mounted to the cast will not sit on the stand in a secure, reproducible fashion. The goal is to make sure the cast is stable and secure. To start analysis, the occlusal surfaces of the teeth should be roughly parallel to the horizontal plane. An exaggerated tilt is usually incorrect. Secure the analyzing rod in the vertical arm of the surveyor. The rod will contact the teeth at the height of contour. Look at proximal 2 surfaces to determine the position that will achieve as much parallelism as possible. Multiple parallel surfaces produce retention. Those parallel surfaces are not just at proximal surfaces of edentulous areas. They can also include line angles of posterior teeth where circumferential clasps encircle the teeth, as well as lingual surfaces. The position of the cast may need to be altered to improve the parallelism. To adjust the anterior-posterior tilt of the cast for the best parallelism of proximal surfaces, brace the cast with one hand, unlock the screw, change the position, and tighten the screw. Now re-examine. Once this anterior-posterior position for parallelism has been decided, look at buccal and lingual surfaces for height of contour and potential retention areas. Play with the orientation of the table to minimize excessive undercuts or equalize the degree of undercut. Brace the cast to attempt to change only the buccal-lingual orientation while maintaining the anterior-posterior position. When the screw is tightened again, check that the guide plane areas have not changed and retentive areas have improved. To help identify contact of the rod to the cast and the amount of curvature at the contact area, look for triangles of light that are formed when the analyzing rod contacts the tooth at the height of contour. Playing with the position of the light source and also background color can be helpful in visualizing these triangles of light. To use a depth gauge to measure the depth of undercut below the height of contour, attach the desired gauge to the surveyor. Adjust the height of the gauge to a position below the height of contour and move the stand so that the shaft of the gauge contacts the tooth. Gently move the gauge until the lip of the gauge contacts the tooth. Simultaneous contact of the shaft and the measuring lip gives an accurate measurement of the depth of undercut at that position on a tooth. To mark the survey line or height of contour on teeth, place a carbon marker supported by its metal sleeve in the vertical arm of the surveyor. Place the carbon along the bulge of a tooth and gently move the stand supporting the cast to place a line on a tooth or teeth. To replicate the position you have achieved, survey or tripod marks need to be marked on the cast. Method 1 is truly a tripod or use of 3 separated points to reproduce the plane of orientation. Move the stand side to side and front to back to select these 3 points. The anterior-posterior points should be as widely separated as possible to maximize accuracy. They should be positioned so that the stand can be moved in any direction and not have part of the cast act as an impediment to movement. When the position for these points have been selected, lock the vertical arm and move the cast to the 3 points, marking a short horizontal line and circling it for each point. This is the method used generally and the one officially used at UB. A classic error is producing a mandibular cast with a high stone tongue. Bulk in the middle of the cast will prevent free movement in any desired direction, making it very difficult to reorient the cast in the future. Method 2 requires fairly parallel sides to the cast base in the survey position. The analyzing rod or the wax trimmer can be used. Place the rod against the cast base and mark multiple parallel lines with a mechanical pencil along the sides and back of the cast. This method is not as accurate as the first for reorientation, but it allows for very rapid orientation. So, if you choose to use parallel lines, always add the circled points for accuracy.